Let's do a breakdown, a very simple breakdown of the different components of some of these systems. So we're gonna divide them in different layers. So on one hand, we have the skeleton. So think about the skeleton, which is what gives a structure to the system and allows the system, for example, to roll. So the skeleton on one hand has a track system that basically you can see here. This is the only physical connection between the system and the apartment, where this track is taped to the floor. This is kind of a small track here, taped to the floor with double-sided tape on these brackets, and then it gets plugged into a conventional outlet. And this allows the system to be guided properly, to know, where it is, but also it brings power into the system. And then the other side of things is the chassis, almost like a car. A car has a chassis with wheels. So here we have this structural chassis. In this case, it's from a pocket closet. So you can see it's smaller, but you can see the chassis, you can see the wheels, you can see the materials, the rubber that we use. We choose the right durometers so that we can kind of work in all these different types of flooring systems. But you can also see bigger chassis, with the bigger systems, bigger wheels, but also always thinking about a skeleton that gives that capacity to the system to move. Now, that's a skeleton. The second part of things is the muscle. You have a skeleton and now you need to activate. So in our case, the muscle would be things like motors, So we are using these small motors, which is what we use for moving the wall left and right, getting the bed in and out, getting the bed, down from the ceiling and up. But the interesting thing from these motors, you can see them in the scale, they're really small. Small motors, and that's important because what that means is that the consumption of these systems when they move, it's really small. It can be about 100 watts when one of these systems moves left and right. And just as a reference, 100 watts, it's 10 times less than a hair dryer that you use. So not only motors, you can think of power electronics that are important, so you can handle all those electric loads properly. So all the power electronics in boxes like this, that have that again, electrical management. So that's kind of the muscle side of things. And then last but not least, you have the brain. Of course, you need the intelligence. We have the Ori square, which is what allows you to kind of interact with the system. But the more interesting thing is that all our electronics have thousands of lines of code. What that does is, on one hand, it's all about safety and reliability. It's all about all the code that, for example, allows a system like this to know the floor, to actually map the floor, know the different distances, and actually use that for safety. So that's kind of one aspect of the brain. The other aspect is that idea of the Internet of Things and how we can connect these systems and make them a smart device, very much like your smart thermostat or your smart lights. So that means that I can, open my phone, I have the app here, and this is what I do here is I have the different presets. I can, of course, control it, but also I can do things like I can lock it so that no one else can move it. I can also change the presets. So if I want my closet to be slightly bigger or slightly smaller, this is what I would do it. I can also use this to connect our system to other smart devices, such as voice control devices. So think about Google Home, Amazon Echo. And for example, in this case, we have both devices there. We can say something like, Alexa, ask Ori to create my closet.
Okay.